Hello friends, in this video we are going to talk about matter waves, or also known as de Broglie waves, or as you call it, de Broglie waves. See, we have two equations of energy. One is applied to radiation, that is E equals to h into nu, and the other equation is when mass is converted to energy, how much energy that you got. E is equals to m into c square. Okay, one is the energy of radiation, other is the energy of matter. Now what if matter is converted into radiation? What if matter behaves like radiation? If matter behaves like radiation, I can apply both the equations to that, and so by comparing both these equations I would get mc square is equals to h nu, right? Nu can be replaced as c upon lambda, because c is equals to lambda into nu. So putting the value of nu over here, I get c upon lambda. Lambda is transposed over here, mc square is transposed over here, one c cancels out, and what I get? Lambda is equals to h by m into c. What is m? Mass. What is c? C is the speed. Mass into speed can also be written as momentum. So what is wavelength? Wavelength is equals to h upon p. It means that if matter is behaving like waves, then we can find the wavelength of that wave. How can I find that? Just divide Planck's constant with the momentum of that particle. Alright, now this was only a hypothesis. This was only a hypothesis given by de Broglie, that if matter behaves like particles, then what will be the wavelength? यानी अगर छोटे छोटे particles wave की तरह behave करते हैं तो उनकी wavelength कैसी होगी? The wavelength can be calculated by using this formula. Now somebody called Davison and Germer, there was a famous experiment carried out by them and they tried to prove this theory. उन्होंने इस theory को prove करने की कोशिश की, prove करके क्या test करने की कोशिश की. And what did they do? They accelerated an electron between the potential difference V. ओके, कोई भी एक सर्टेन वोल्ट का पोटेंशियल डिफरेंस लगाया दो पॉइंट्स के बीच में और वहां पे इलेक्ट्रॉन को छोड़ दिया. सो इलेक्ट्रॉन वाज एक्सिलरेटेड बाय दैट इलेक्ट्रिक पोटेंशियल. सो काइनेटिक एनर्जी ऑफ द इलेक्ट्रॉन्स बिकम इक्वल टू E into V. E into V, the same manner in which we calculate electrostatic potential energy. Here, the potential energy, electrostatic potential energy gets converted into kinetic energy. Okay, so kinetic energy of that electron was E into V. Charge of electron into the potential difference applied. The momentum of the particle. What is the momentum of particle given as? The relation between momentum and kinetic energy, it is square root of 2mke. Put the value of kinetic energy over here, that is E into V. This is how we find momentum. And now put this momentum into the equation of wavelength. So what you get is lambda is equals to h by p from here, and put the value of p into this equation, that is h upon root of 2mev. H is Planck's constant, m is mass of electron, E is the charge of electron. Put all these value here, do the calculations, and this is what is the number you are getting. Lambda is equals to 12.27 upon square root of V into 10 to the power minus 10 meters. This number 10 to the power minus 10 meters is also known by the name of angstrom. Okay, so if you have calculated or if you have accelerated the electron by a potential difference of 1 volt, put that 1 volt over here, you will get the wavelength. If you have accelerated it by 25 volts, put 25 volts over here and you will get the wavelength of that particular electron. They not only did this in theory, but they also carried out an experiment known by the name of the famous Davison-Germer experiment. Of course, you don't have to prepare these experiment now, it is moved out of the syllabus, but this theory of particles behaving like waves, or you can call it the de Broglie waves, or you can call it the matter waves.